Good morning to all my dear students. So in this class I am going to take a class in on paper operating system. So it is core course of BSc third semester, and this uh, class can also see by the students of HS Computer Science, BSc General, BCA, MCA courses also. So in this class, I'm going to discuss introduction part of the operating system. So introduction to operating system. So from general definitions, what is operating system? Actually, operating system is a system software. We know this. So it is an interaction between user and computer system. So an operating system is a program which acts as an interface between computer system, users, and the computer hardware. So it is an interface between user and computer system. Secondly, operating system provides a user-friendly environment in which a user may easily develop and execute programs. Otherwise, hardware knowledge would be mandatory for computer programming. So, it can be said that operating system hides the complexity of hardware from uninterested users. In general, a computer system has some resources we have already known which may be utilized to solve a problem, that are memory, processor or CPU, input output or peripheral devices, file system, etc. These are some important resources. So the operating system manages these resources and allocates them to specified programs and users. With the management of the operating system, a programmer is rid of difficult hardware considerations. An operating system provides services for lots of services actually provided by operating system. Number one, important services, processor management. Actually, in computer system we count lots of processes. Processes is nothing but an executing program is known as process. So that processes are managed by processor. So processor management is one of the important services of operating system. Next, memory management. So memory is another important resources of computer system we have already known. So memory management is done by operating system. Next, file management. File means lots of directories and files are data are stored in the form of files and directories. So which file when created, which directory is when created, what type of files were stored, this type of management is done by operating system. Then device management. So it is also input output, peripheral device, input output devices, peripheral devices, all are managed by the operating system. Then concurrency control. So lots of programs are running in the computer system. So which program run when, these are determined by the operating system. Now another aspect for the uses of OS is that it is used as predefined library for hardware and software interactions. So, and this is why system programs apply to the installed OS since they cannot reach hardware directly. So operating, here we see the scenario. In the upper level, application programs, then system programs, then operating system in the third layer, and then machine language and hardware, finally hardware. So this layer architecture of the computer system is actually operating system is in the middle positions. So application programs and system program are interacted through operating system with the hardware. So it is also important to interact all application and system programs with the hardware through operating system. Now a simple program segment with no hardware considerations. Basically when we do some programs, there is no concept of hardware. Then operating system came and the system program or application program are interacted through ways, and it becomes a more sophisticated program segment with the hardware consideration. So it interacts with the hardware. And finally machine language translate this program segment to give response hardware, because in hardware only 0 and 1 machine code binary bits is actually in the hardware. They only understand memory bits. So machine language convert this sophisticated program segment into a machine language, and it finally hardware response. With the advantage of easier programming provided by OS, the hardware, its machine language and operating system constitute a new combination called a virtual extended machine. Actually, when operating system came with the interaction of machines, so machine is just machine language and hardware. So when an operating system comes as interactions in the upper layer, so it becomes virtual extended machine. So operating system added with the machines, then machine language, then hardware. So this is also one of advantage for easier programming done by the OS. In a more sophisticated approach, in fact, OS itself is a program. So OS, we have already known that OS is a system software through which system runs. So OS itself is a set of programs. But it has a priority which application programs don't have. Actually, application programs are some programs which are specific to some applications, and actually OS helps application programs so that it smoothly run in the system. So that is why OS operating system has higher priority. OS use the kernel mode of the microprocessor, whereas other programs use the user mode. So application program runs in the user mode, but OS operating system use kernel mode, which is the core of the system. So core of the microprocessor. So the difference between two is that all hardware instructions are valid in kernel mode. So when we deal with the hardware, it is actually valid in kernel mode, where some of them cannot be used in user mode. In user level, in user mode, we cannot solve the hardware problems, hardware instructions to run smoothly. So this is important concept. Now come to the history of the operating system. So actually it is all start with computer hardware in about 1940, when ENIAC first computer system in 1943. So it's next ENIAC, we know that electronic numerical integrator and computer at the US Army's Burden Proving Ground, Maryland. So built 1940s, then weighted 30 tons ENIAC machines. These are the actually first generation of computer. So this is the how what is the size of computer system in a machine. Next, in the second generations, computer were using vacuum tube technology. So vacuum tube technology comes in the second generations. Then programs were loaded into memory usually using switch, punch card and paper taps. Punch card and paper taps. And Babbage analytical machines designed by 1840 by Cyril Babbage but could not be constructed by him. Simpler and earlier and simpler version is constructed in 2002 in London. Then Ada Lovelace at the time of Charles Babbage wrote code for analytic engines to computer Bernoulli numbers. As time went on, card reader, printers, and magnetic taps units were developed as additional hardware elements. Similarly, assemblers, loaders, and simply utility libraries, which are actually language processors, were developed as software tools. Later, offline spooling and channel programs method were developed sequentially. Finally, the idea of multiprogramming comes. So multiprogramming means sharing of resource between more than one processors. Then this type of operating system, multiprogramming operating systems, helps. By multiprogramming, the CPU time is not wasted because while one process moves on some I/O, input-output works, the OS picks another process to execute till the current one passes to I/O operations. Next, time sharing system comes with the development of interactive computations. In 1970s, time sharing systems emerged. In the system, multiple users have terminals connected to a main computer and execute their tasks in the main computer. If we see the history, main computer having a CPU executing process by utilization of OS, like Linux, Unix. Terminals are connected to the main computers. These are and used for input and output. No processing is made. They don't have the CPU. This is just main computer CPU. They are terminals. Another computer system in a multiprocessor system. It is also having multiple processors sharing memory and peripheral devices. So here the OS is multiprocessing. Here also OS helps multiprocessor system to run smoothly. With this configuration, they have greater computing power and higher reliability. Multiprocessor systems are classified into two or tightly coupled and loosely coupled. In tightly coupled one, each processor is assigned a specific duty, but processor works in close associations, possibly sharing the same memory. In loosely coupled, which is also known as distributed system, each processor has its own memory and copy of the OS. Use of the networks requires OS appropriate for them. In network system, each process runs in its own. Finally, network operating system comes. In network system, each process runs in its own machines, but the OS have access to other machines. By this way, file sharing, messaging, etc. become possible. In networks, users are aware of the fact that he or she is working in a network, and when information is exchanged, the user explicitly handles and transfer of information. So each is a computer having its own CPU, RAM, etc. and operating system support network in the installed on them by using network operating system. So finally, again come distributed systems are similar to a network operating system. However, in such system there is no need to exchange information explicitly. It is handled by OS itself whenever necessary. So with the continuous innovations, new architectures and compatible operating systems are developed, but their details are not in the scope of this text, since the objective here is to give only general view or introduction part. So Thank you. And next class we go details another part of the operating systems. Okay, thank you.